Assalamu alaikum. I am Sarwat Jamal. I would like to deliver my lecture on BCS course files and databases under the supervision and guidance of College Education Department, Government of Sindh, and our well-esteemed principal Professor Khalida Parveen. After completing today's lecture, we will be able to learn different ways of storing data before the advent of computers, early database systems, early database models, which includes hierarchical model, network model, the relational database model, traditional file processing systems, and integrated database environment. Our lives are flooded with all kinds of information. Thanks to computer databases, we interact with information easily and seamlessly on a daily basis. Human beings began to store information very long ago, before the advent of computers. This Sumerian tablet is an index of medical prescription, this ship manifest, card catalogs, product inventories were the different ways to organize and store data manually. Before the use of computer, manual file systems were used to maintain records and files. All the data was used in manual files. It was time consuming, inefficient, and lot of labor work was required. Now, with the advent of computers, manual file systems were replaced by traditional file processing systems. This system was able to cope up with the disadvantages. The flat file system consisted of a simple consecutive list of records, and this computer readable data was stored on magnetic tape or hard disk. The mechanism used to search records was sequential search, which was tedious and slow, and it was very difficult to maintain large volumes of records. Overall, traditional file processing system was good in many cases as comparison with manual non-computer based system, but still it had many disadvantages that was overcome by database systems. So new, faster databases were needed that were expandable, reliable, and efficient. In the mid 1960s, International Business Machines (IBM) used a hierarchical model for their information management system (IMS), which was successfully used by NASA to manage drawings for the lunar lander. Hierarchical database model. So we can see data is organized into a tree-like structure. It is stored into tree-like structure as records which are connected to one and other through links or pointers. Each child has only one parent. Each parent record can have one or more child records. A hierarchical database model is a data model in which the data are organized into a tree-like structure. What is meant by a tree-like structure? Here in this diagram, we can see that the hierarchical database model mandates that each child record has only one parent, whereas each parent record can have one or more child records. In order to retrieve data from a hierarchical database, the whole tree needs to be traversed starting from the root node. This model is recognized as the first database model created by IBM in the 1960s. Then we have the network database model. The network database model was invented by Charles Beckman in 1969 as an enhancement of the already existing database model, and the model was highly flawed Beckman decided to create a database that is similar to the hierarchical database but with more flexibility and less defaults. And the original and existing hierarchical database has one parent file linked strictly to one child file, creating a ladder effect that restricted the database to find relationships outside of its category. As we can see, it has many to many relationships. It has great flexibility among the information files because the multiple relationships among the file. Because it has many to many relationship, network database model can easily be accessed in any table records in the database. For more complex data, it is easy to use because of the multiple relationships founded among its data. It is easy to navigate and search for information because of its flexibility. Here we can see in the diagram, one child can have more than one parent and one parent can have more than one or more than one child as well, children as well. Now comes the relational database model. In this model, we can see that Ted Code, a computer scientist at International Business Machines (IBM), had a better idea. His relational database model, which he first proposed in 1970, organized a body of data into simple tables of related information. There were no pointers to maintain because tables are connected only by having matching data fields. This made it easier to access, merge, and change. So in relational database, the data is presented to the user as relations. A presentation in tabular form is as a collection of tables with each table consisting of a set of rows and columns. As we can see, each table consists of rows and columns and provides relational operators to manipulate the data in tabular format. In 1970s, two relational database systems prototypes were created, namely Ingress and System R. Ingress used a query language known as Quell, and it led to the creation of MS SQL Server, Sybase, Rackspace, and System R, on the other hand, contributed to the development of SQL, DS, DB2, Allbase, Oracle, which is very famous, and SQL is structured query language. SQL became the standard query language. The relational database systems became a commercial success. Now, traditional file processing system. All the information is stored in files. It was totally computer-based system where all the information is stored in different computer files. All traditional file system stores data in a manner that all the departments of an organization can have their own set of files that create redundancy. Files carrying data are independent of each other, say COBOL, C++, Pascal. Let's take the example to illustrate the traditional file processing system definitions. Let's take an example of college where the student record for examination is stored in different other files, and it has library record and is stored in different file that creates many duplicate values. We can see we have three different department: library, examination, and registration. Each department is having their own database application. As we can see, program library application, and the files maintain the records just like registration data and files. So it means the data and program depends upon each other, and due to this, any change in one file will affect the other file too. So we can see program and data are dependent on each other, and we can see few disadvantages associated with traditional file system, or it is also called as flat file system. Data redundancy. Each application has its own data file, so same data may have to be recorded and stored in many times. Data inconsistency. Data inconsistency means due to the same data items that appear in more than one file do not get updated simultaneously in each and every file. Then we have data dependency. Program and applications in the file processing systems are data dependent, but the program is incompatible with file format. Then we have limited data sharing and security problem. Then we had retrieval problem as well, and lack of accessibility. The data was not accessible. And to overcome these disadvantages of file processing system, integrated database systems were introduced, and a few advantages of integrated database systems are less data redundancy, less data inconsistency, integrity resolution, and better data security. Well, let's see what happens in integrated database environment. Integrated database environment has a single large repository of data, as we can see in the figure, and which is called data repository or database, which is simultaneously used by many different users and departments, and it is accessed or owned by a database administrator. All access to database is controlled by a sophisticated software package called database management system. All the data about all the information that resides in all these application programs is stored in a single file called database. The data in a database is integrated, self-describing, interrelated. And what are some of the benefits of integrated database environment? We can see, first of all, sharing of data. The database manager manages the data, but it does not belong to any individual or department. Many users can be authorized to access the same piece of information. It means many users can simultaneously access the same information. They don't need to wait. The second one, advantages, control of redundancy. As we can see in file processing system, a lot of space is wasted because of storing same information in two or more files. But here in integrated environment, information is integrated so that several copies of same data are not stored. So we don't need to store the information at different places, at different locations, the same information again and again. So some limited redundancy is permitted to keep logical connections among data items or to improve the performance. Then we have data consistency. One effect of eliminating or controlling redundancy is that the data is consistent. If a data item appears only once, any update to its value needs to be performed only once, and all users have immediate access to the new values. If the system has some controlled redundancy, when it receives an update to an item that appears more than once, it can often do cascading updates, automatically updating every occurrence of that item, keeping the database consistent. Then we have improved data standards. The DBA, the database administrator, who is responsible for designing and maintaining the database to serve the needs of all users, must define and enforce organization-wide standards for representation of data in the database. Then we have better data security. Data security is the protection of the database from unauthorized access. All authorized access to the database is through the DBMS, which can require that users go through security procedures or use additional passwords to gain access to data. Then we have improved data integrity. Some database management systems allow the database to define integrity constraints or consistency rules that the database must obey. So these constraints may apply to items with a record or intra-record constraints or to the relationships between records or maybe general constraints. Then we have balancing of conflicting requirements. Each department or individual user has data needs that may be in conflict with those of other users. The DBA is aware of needs of all users and can make decisions about the design, use, and maintenance of the database that provide the best solutions for the organization as a whole. Then we have fast development of new application. A well-designed database provides an accurate model of the operations of the organization. When a new application is proposed, it is likely that the data required is already stored in the database. Development time is reduced because no file creation phase is needed for the new application. So we stop the lecture here. Students, inshallah, I'll come up with new topic. Thank you.